Morning.
Morning, how are you?
Good. How are you? How's your
I'm
vacation?
good. Yeah, it was good. I was traveling, so got back on Sunday and yeah, it was good.
That's good to hear. Yeah, I feel like we had a little bit longer of a break this time, so I hope everybody's happy, rest.
Yeah. Did you guys finish this chapter when I was away or continue reading it?
I think we got almost there, but everybody wanted to just kind of review it one more time,
Sure.
So
Yeah,
actually, since Amelia is here today, like I think we can kind of go with her direction for today's time because I know she wanted to review everything.
sure.
Hey, Amelia.
Hey, good morning, guys.
Morning.
Good morning, Amelia.
Oh, Ramya is back.
Yeah, I'm back.
Yeah. So yeah, I think we left that the topic to Ramya to finish up, right? Do we want to go with that Avro schema?
Oh, right. I guess you want to go back to the point you were explaining Avro.
Sure.
I think we might have skipped that. Do you know what page that was, Amelia?
That was in my book. It's 122. So.
Okay. Do you know what it starts with, like the section?
The section is after the JSON XML thrift protocol buffer. Yeah, there we are.
Okay, Avro. Okay.
All right, whenever you're ready.
Prepared only. I mean, if you're not prepared, then we will do something else.
Yeah.
I have my notes from my textbook, so I'll read out of it, whatever I remember for Avro, and it might summarize things, and later you can go back and read that section. So, summary for Avro is it is yet another binary protocol, and it doesn't use. It also has a schema, but it doesn't transmit schema during its serialization process. All the previous protocols we have seen so far had some form of schema in their serialization format, either as a field name or as a tag name. Remember, like had a tag numbers, right? Here, it doesn't need to do anything. It just needs to send the field values. For example, for the record here, username, favorite number, and interests, it just transmits the value for these records. That's why it's the most compact format. Though it tells something about the length of the field, it transmits something like if it's if username is 6 bytes, it says it's 6 bytes, and the favorite number is somewhat of it uses again a variable length encoding for integers, so it says the length of the field before any field value, but it doesn't transmit length. What is that? The
attribute code.
Yeah, it doesn't transmit the tag, or it doesn't transmit the data type. Like it doesn't say it is a string, or it doesn't say it is an integer. All that information is only present in the schema. So, and there is a, how does the sender and the receiver incorporate this serialization, right? The sender has a schema and the receiver also has a schema. And both these schemas, if they ideally match, then there is no a problem, right? Because what you write and what you wanted to read out of it are same. But as we know, when we are upgrading systems in a rollout fashion, the sender schema and writer schema can differ. So how do we take care of this? Avro has a layer for above this, and this what this exactly does is they version the schema. When they send a record, when they serialize it, they have something to say which version of the schema it is. And when they read it, the reader will have a schema, and there is the deserialization layer will do some resolution. It has access to both writer schema and reader schema. Imagine all the schema is also in some database table, and it will get the writer schema and the reader schema and resolve the differences. There are some differences it can resolve and some differences it cannot resolve. A simple name change or a field name change can be resolved. Something like there is a forward compatibility and backward compatibility rules of what it can exactly resolve and what it cannot resolve. Change in the order can be resolved. For example, in the given example, the figure 4.6, username is the first field, but in the reader schema, username is the third field. So change in order can be resolved. Next, the change in data type can be resolved to a certain extent. For example, long to an integer, you will have some loss in precision, so it will act accordingly. I didn't read about the schema evolution exactly, but the general crux is it has access to both readers and writers, and it can resolve the differences to a certain extent. This is how they achieve both forward and backward incompatibility.
Yeah.
But the disadvantages is you have to version the schemas and you have to put the schemas also in a database that may add to the deserialization time. It might not be as fast as other things, because other things you have some form of schema transmitted in your binary bytes and you can read directly. Here you will have to access and do some resolution, and probably Karthik, I think, brought up this point last time. That's why it is not quite adopted like other protocols because of the difficulty of usage.
Mm-hmm. Yeah,
that's about it for Avro from me.
Right. Yeah. Yeah. So I think So when you were gone, Ramya, so we just I think Subha also missed last class. So what we went over was the REST and RPC. Basically, the data flow through different when is this deserialization and serialization used? That's databases and then REST and RPC and message brokers. So REST and RPC, as we all know, it's basically then the client server communication. We use when is it appropriate to use REST and when is it appropriate to use RPC? What is the thinking behind adopting RPC? Why did it even evolve? So the idea was to kind of make the network calls look similar to what a local method call would look like. But that kind of does not do the justice to the problems that the network, the network calls would normally face, like timeouts and then, the remote server not being available. So all those don't happen in a local procedural call, right? So that's why RPC is not widely adopted, because it's not exactly suited for the network communication. So for REST, so the among the web services also there are two families, like the REST based services and the SOAP based services. REST is more open-ended. It's more it's easily the fact that it does not have so much of it's not so strictly enforced. With SOAP you have XML based schema that is enforced, and you can't just bring up Postman without that, the schema. You need to have that schema definition file with you to be able to even make a simple call. With REST, you just need to know the URL and the required fields, and you'll just be able to make a call. With SOAP, it's so because it is so hard to use without explicit adoption of tools to make it happen. So SOAP is less widely adopted. it is more secure because of its hard to adopt thing, but yeah, it's also not popular because of the same reason. And we also spoke about the next pass was about the asynchronous data flow, where basically there are that's another place where serialization is used, where there's a producer there's a producer which basically produces an event based architectures, right? So producers produce these events, and they're in serialized form, and there's a message broker, the intermediate actor, which kind of buffers these and kind of delivers them to the subscribers. So it's like not one-to-one, one-to-many kind of architecture. So it's kind of producer and subscribers are completely disengaged. Producer is not concerned about, it just emits the event and forget about it. It's not waiting for a response from subscriber. So that's the asynchronous message passing that's the last section. So what do we want to do next? Do we want to
I think you got us back to exactly where we stopped, distributed actor frameworks.
Yeah, so. Actor frameworks I didn't read. So should we take a minute? Maybe we can just read it out here, like take 5 minutes to read and then discuss.
Yeah. If you want that, has anybody else read this? Just asking, because we can popcorn as well.
Yeah, sorry about that. What was that, Vijay?
Oh, I was just going to say, has anyone else read to this point or read the chapter? Does anyone want to take this section here and just give the summary?
Actor model, right? It didn't seem like a simple concept, I mean, here he just touched upon it, but it's a deeper concept. So basically he says actor model is a programming model for concurrency in a single process. So actor model is alternative to the threads that we, the thread model, not thread, the threads, concurrency, right? We achieve concurrency by spawning threads. So he says it's an alternative to threads. That I don't understand, because thread is an operation, OS concept, right? What do you mean by, it needs more deeper dive. It's not completely captured in this small paragraph here. So yeah.
So threading, how does it work? Like really, right? Think of it. Let's take any services, web service, REST service, whatever service you're talking about. Every request, let's say Amulia is calling, I'm calling, and Vijay is calling. What happens underneath the hood is like a thread is spawned for every request. That's how it maintains the idempotency and the whole atomicity of that particular request, right? So I call, so let's say it's a put or a patch. So my entry is like segregated as a separate transaction where it doesn't get like bleeded into another transaction. So that's how it's actually maintained behind the scene. As a thread is spawned for every request. Be it like not just services, even in basic J2E, right? Back in days in Corba and everything, a thread is spawned. So that's what he means by threading here, right? Internally, the frameworks and the server itself will handle to make sure that everything is independent and none of the transactions bleed into other transactions. So that's exactly what he means by thread. Going back to the actor model. So let's say if we want to support more concurrency, how would we do? We don't have control. So as a J2E pattern itself, like it's generally an anti-pattern to use threading in your web services. We never touch threading, right? Because it's under the hood, the server handles it, the frameworks handle it, which is abstracted for us. Mm-hmm. So if we want to support high concurrency, right? What we would generally do is generally increase the load balancing capability of the system itself, right? Whereby we add more vertical nodes in a clustering mode, or sometimes it could be even horizontal nodes, right? Mostly horizontal nodes. Or you can move into a bigger machine which has more threading capacity, right, under the hood, OS and stuff, or you can share the load with round robin mechanism, right? So that it supports at any given point more requests and it's able to handle it. Now, that is just for concurrency on how much load it can take, not exactly the transaction itself, because transaction it's highly dependent on the business logic anyways, right? So that's going to actually drive your concurrency measures on the SLA. Now here in this case, if you guys are familiar with something called a reactive manifesto. So what is reactive manifesto is like, what it says is everything is message driven. In an actor model, everything is kind of message driven. So I know when I say message driven, you don't have to bring in RabbitMQ or Kafka or SNS SQS, but the framework itself has this mechanism in it, right? So when a caller is calling, it has basically the reactive manifesto has 4 main principles. Elasticity, which like think of it like scale in, scale out at a very miniature level. And then like, location transparency and message driven attributes. So anyone calls a particular service, the actor model, what it does is like it's a non-blocking call internally, and then it just sends the message to, hey, this is the transaction that you need to do, and then it waits on those transactions, right? Like internally, actor will send it to the respective calling system, and then calling system internally, though they are part of a single unit, it's driven in a little conceptually little different way, where by using that mechanism, just like what benefit we get from a true asynchronous messaging system, you get it here as well. I don't know if you guys are familiar with frameworks like Akka and stuff. These are built on top of this mechanism, whole reactive manifesto. And reactive frameworks have come a lot of other areas, right? Like Quarkus and stuff like that in Java area as well. These Spring Reactive and stuff, if that makes sense.
Okay, so it's called reactive programming. Okay.
Yeah, just type reactive manifesto. The manifesto is written sometime back, and then like Agile manifesto, there are 4 main principles: message driven, elasticity, location transparency, and another.
Got it. Nice. Yeah, I will read up about this and update our notes on this. Thanks for that. Thanks for that talk. I mean, I didn't completely understand, but yeah, I think I need to read up after this. I'll update the notes, guys. So next time we can probably go over it. And yeah, anybody has any questions? Yeah. Okay. So what do we do? Do we want to start the next chapter today, or should we go over a design question? I wanted to go over a design question. So hopefully what do you guys think? We can go over,
Let's do that on Friday. Let's plan for one, just so that we have enough time to think about it too. But right. I guess what we could do today is ask, like, what are some questions that, we could try, or we could talk at this time about like everything that we've learned, and then, maybe give ourselves homework.
Yeah. But is everybody comfortable with chapter 3 and like our comfort? I think the gist of it is like, in a day-to-day design work, at work, what you want to design. If you want to design high compact payloads, then we now know that there are some tools, some schema languages that we can take advantage of, that can basically go with any programming language that you're using, the protocol buffers, Thrift and Avro stuff. And also why was yeah, how does RPC and REST compare? And then the message brokers, and then like what Karthik just touched upon, the actor model and the Reactive Manifesto, right? So I think we are I think the notes is still lagging behind. I'll update that so this weekend. Yeah.
Okay. Yeah, I mean, like, I just kind of pulled the table of contents here just to, kind of show an outline. Sometimes, like when I'm thinking about notes, right? Like I just look at outlines from the table of contents just to kind of like gloss over and remember, oh, okay, this is exactly what I went through. So, I mean, like, this right here kind of is a pretty good, recap of what we learned in chapter 1. Then chapter 2 here, right? Like all the query languages. Remember, like map reduce, one to many, many to one. Then the graphs. This I think was like the biggest part of the chapter, like the newest thing for me, right? Like learning about like Neo4j and graph traversal. Then we went through storage and retrieval. And then this was also pretty new to me too, because like this is talking about like how, the searching was done to find data and the different types of data structures they used, like B trees and nested tables, LSM trees. Then we had the compression to column-oriented compression, or column-oriented storage, aggregation. Then moving into this chapter, right, we learned about encoding, then different formats, JSON, XML, and binary variants, thrift and protocol buffers, Avro, schemas, data flow, REST and RPC, and then message passing data flow. So I would say like pretty much, if anybody has like questions about this stuff, or if anyone wants to do something around this, speak now. Let us know.
Do you remember where you would want to use graph database?
Yeah, I mean, like, if you're basically exploring like many-to-many relationships, it's a good place to use a graph type database. It's probably better than using SQL, because SQL you end up writing more queries. And actually, my friend, like, I don't know if I mentioned to this to you all last time, but I guess he got a job at Neo4j. Yeah, and I know that they're having a conference. In fact, let's see here. It might be in my other tab here that I quietly put away. So there was some talks this week about Neo4j, and he told me, like, oh, it was in Texas, so if I wanted to go, I could go. Fortunately, my mom is got sick over the weekend, so I couldn't go. But this was interesting to me, so yeah, we could. One idea I had was, we could maybe, watch one of these events or check out like one of these events and then give a summary on what we learned, like what's current, what's modern. So maybe going through and just checking out what happened at the latest conference, because it seems like today's the last day. So maybe, get the cliff notes and share that with the group. That could be one exercise. And then explain to us how this works, right? Like at a very basic level. Then also, I think like, because the chapter was kind of hard, right? Maybe we could talk about thrift and protocol buffers in more explanation. That was something that I put as a tab to do for myself. Maybe go through this tutorial from Google, right? And just kind of understand what was going through. So this could be like an exercise. We could read this. Somebody could read this and give a summary on it. So this is like stuff I was thinking like people could do. I think we talked about Envoy. Somebody said this was important. Maybe that was Akanksha.
What was that? Envoy? What?
Yeah. She said, like she said at the last meeting, I think she said that she wanted us to talk about Envoy. It was a brand new thing that came out. And it was pretty much related to what we were going through and learning. So she wanted us to take a look at this. It has gRPC support.
What is haproxy? I've heard of that word. Does anybody know what that is? Built on the learning solutions such as Nginx and haproxy.
Ch4 is like, think of it like Apache, the HTTP server, or Nginx, right? Does the load balancing. It's like a software load balancer of sorts, right? There are hardware load balancers like F5.
Okay. But like, don't
redirects and stuff. If right, Ch4 is another open source solution which is widely used, right? As well, like Nginx.
What does software load balancer mean? Like, it's kind of.
So think of it like, let's say you have two. Let's say you want to host two APIs, right? And you want to distribute the load to both the APIs. So there will be a load balancer in front of it, which is going to do the round robin, like based on either IP. There are different ways to configure it based on the IP, geolocation, and stuff. It will route to one instance of the server, the first request. Second request, it might route to the second server, so that it makes sure that none of the servers are loaded. So it has a TCP connection to these behind the scenes servers, right? So the clients always hit the front end load balancer. So these are all software load balancers, but there are hardware load balancers which are appliances. When I say hardware load balancers, like F5, they're all hardware load balancers which has much more capability. It's deployed in a data center back in days, right? Like pretty much think of it like Route 53 for us in AWS, if we will, right? So which has capability to do all these round robin, geolocation, session-based URL, or even IP-based tracing, and then route to appropriate servers. Let's say someone accessing from Asia, they have a server deployed in Asia as well. It needs to get routed to Asia, or like, Europe for GDPR and stuff like that. So yeah, it can do proxy forward, round robining, load balancing, right? So Apache, Nginx, Ch4, everything fit there. FI, and like there are a few more, and doesn't, for example, even Zscaler, and a lot of other hardware load balancer accelerators are there. So hardware load balancer and accelerator also in them have capability to do caching with CDN capability. So yeah, they're much more expensive, and they generally are deployed in data centers.
So do out of the box. So basically your haproxy and all this, the Ch4 and this Nginx, right? It's a layer of servers in front of the Tomcat servers.
Yeah. So purely for it has much more capability. It can also host HTMLs too, like SPA applications you can host as well, right? In these things, and then it has capability to do the proxy forwards, redirects, and stuff like that. So basically, it's a HTTP server, right? Pure implementation of a HTTP, TCP level HTTP server, and then it has capability to host web application at a HTTP layer. If you want to experiment, or I want to experiment, we can't experiment with hardware load balancers, right? In the laptop or whatever, right? If you have just a very simple hello world application, if you're running two instances of it locally on your machine on different ports, right? Because or even Tomcat, you're deploying a simple application in Tomcat. One you're running in port 8080, another you want to run on 8081 just for the sake of it, right? And then in the load balancer, you will just hook it up to 80, right? That's the basic, or if it's HTTPS 443, and then from there it internally connect to these 8080 port and 8081. So One is like it'll encapsulate from actual consumer who's the service is exposed to. They wouldn't know what is a port running, how many instances are running, and stuff like that. Tomorrow, you want to add more servers to it to handle the load. It's like, it's easy, right? Rolling updates can be done. You can just add, remove, or even do updates. Or if you want to change port for whatever reason, you can do all those things without affecting the actual consumer of the service, right? So some kind of abstraction, and then it provides other benefits as well. The round robin mechanism, if you choose to, or you can do affinity based routing to a particular server and stuff for the load.
Got it. I think in this cloud age, right, we don't kind of manually bring up our own load balances. I think probably if you are on ELB team, maybe you would be wondering what implementation, what exact implementation you would want to use in your ELB implementation, I guess, right? So I think that's why we are so unaware of these things.
Yeah. I mean, even ELB team, you need to, with the amount of products that we have, you need to carefully choose for use cases, right? Why would you use NLB versus ALB? What are the benefits and pros and cons? And for you to be able to make that decision, you kind of should know underneath the hood what's going on. Right? Yeah. So
Yeah. Good topic. Thanks for that, Karthik.
No problem.
Okay.
So one small point on the graph database. Yes, many to many. Again, going back, like many to many, even NoSQL support. What is the differentiation here is like, if you want to compare, contrast a query many to many of the same data model, right? Graph, you would use, let's say, typically if you go to RDBMS, if you have a data model, let's say user, just a simple thing, like users are in a single table, right? Multiple user, me, you, Vijay, Amulya. So if you want to do querying on Amulya versus Vijay versus me, then graph works better. Similar data models, many to many relationship, but compare, contrast within the rows itself, right? Otherwise, NoSQL is just fine. So that's a finer line on the graph. Basically, connected, same kind of profiles, be able to filter, apply some querying logic, and stuff like that.
Applying some yeah. So basically, if you have many to many relation, and so if you want, basically that many to many concept itself is hard to represent in the the rest, right? Like the SQL and the NoSQL. So yeah, even for the basic model to actually accurately represent the real world relation, many so that's why graph is adopted. There probably is a way to kind of represent it in a hacky way in relational databases, but then you will have to do a whole bunch of joins to come up with a simple query, right? So the example that the textbook talks about is essentially so basically, if you want to know, like for example, there are people who are born in a particular city in a particular country. So I think that's the example, right? Can we go over that the chapter? So where is that? So basically Facebook is an example, right, where you want to know the relationships, like I have so many friends, and the friends have friends. So this is, it's not so basically if I want to know who does this person a random person, given a person, does he exist in my friend network? Like is he a friend of friends? So if you want to answer that question in a traditional relational database, you cannot have that, because now each friend becomes an attribute, which is hard to represent in a relational database. I think that's where the graph DB does the job, right? And in this example, they gave like people who exist. So I think just a diagram somewhere, right? The example 2.5. So they're saying, yeah, a person can live. He was born in a state, and then he lived in a separate state, and then married to a person who lives in a different state. So if you want to know associations, like given a state, given a city, basically give me all the city associations of a person. Then right, if I search for a city and I want to know if this person has any association with the city. So I think those kind of queries are better answered in graph database, right? Is that what you
just
yeah. That's
Okay,
So I was
just
just
to
gonna
add
say.
to whatever Karthik said, right? I mean, I like the way he said, I like to imagine it this way. At least in relational, right? When you need to connect two different entities altogether. Say for example, user purchasing some product or something like that. Product is totally different and user is totally different. So both of these, if you put it in a separate tables and say user, how many users are purchasing product, and what are the products purchased by which user. So when you have many to many relationships, then you go for a relational. But in a graph, right, typically when you have to make a model where within the same column, when you have to make between different rows in the same column, and you have to establish some relationship. Say for example, here we are trying to establish a relationship between the same type person, but I'm also a person, Amila is also a person, Vijay is a person, Karthik is a person, but we are trying to establish a relationship between all these four. So that is when the graph probably comes into picture better. But yeah, we can, I don't know, maybe the city, right? We can probably model it in a relational DB as well. So again, we may want to pick some example and then drill down to see which suits better.
No, but like I could be so defining new relationships, like so this born in and lives in relationship, right? So let's say there's a new relationship that came again tomorrow that say works in relationship, right? So
all those things are good in graph. So all these things are related to the same person entity.
Yeah,
correct. So it is essentially within the same column, different, you're just trying to put some labels kind of a thing.
Any many to many relationship in the same entity. Connected, it could be connected, or it could be even we could be writing who is not connected query too, right? In the same entity, if we were to establish, think of in RDBMS, if we have multiple roles, basically we are querying against the rows itself, right? Comparing, contrasting between the rows itself. If we were to do in RDBMS, what we will do, we'll query everything, and then we'll do this in the application logic, right? Okay, segregate who lives in Bay Area or California, who lives in India and stuff, right? Between as a person or a user entity. So graph shines well, like even in a single graph structure, we'll be able to query because it's all like connected profiles kind of a thing. If you are to talk about Facebook or LinkedIn, whatever, it's all connected entities. So we are querying against the connected entities. So that's the linkage, and also provides the capability to have some properties. Like for example, we might have some properties, more properties than some other entity or just one particular profile entity. So yeah, in RDBMS, it's relatively tough, right? You still have to define that column. You might have null in it for some people who don't have those values and stuff like that. So it brings a different concept altogether, right?
Yeah. No, but what did you mean by saying compare and contrast between the rows? That's the thing that I didn't understand.
No, when I say compare and contrast, is like querying, right? Basically, you are querying against, okay, just give me all the entities that lives in California, just for example, right? Right? It can be in RDBMS as well, right? This example can be in RDBMS as well. It's not like complex. And the same way you can say, okay, who is not in California as well can be done in RDBMS. But what graph is a different way that where it's let's say if I want to see query, okay, everybody lives in California, and who, let's say there is no property, and I can still do graph some kind of a query on some of the attribute. I don't know how to put it. Maybe I should think a little bit more with a good example and come back. It's there in my head, but I'm not able to explain it right away.
I think we need a good example where we can take up some system design question where we can say, okay, this is the best model. Graph is the best model to choose. I mean, we can choose for it.
Right. Yeah.
Or maybe we should try the other way around. Typically, all these social networks are modeled in graph, right? Probably we should try to model it in RelationDB and see why it becomes a challenge, or why is it not preferred kind.
Right.
So that way we may be able to understand the real value of using a graph.
Right. So, yeah, I from the diagram, it seems to say that you can kind of dynamically represent a new relationship. Now, if you want to add a new relationship, right? So the relationships between the nodes can be different types. So you could be my friend via a different friend. So you are still in my graph, but in my reach or in my social circle, but not directly, but you are like an indirect friend. Or like, for example, I could be associated with a city, not directly, but because I'm married to someone who is or I have a friend who's basically is associated with that city. So I think like indirect relationships can be, I mean, that's like impossible to represent in.
But if you see, you can always model this as well, right? So you can have a person, you can have city, you can have country, you can have, I mean, probably we'll have to think about how do you represent, say you have person and then city and what is there given? State, for example, right? So it's like one of them says born and one of them says lives in. So maybe these two are two different things, right? In a relational world, how do you, it'll basically mean the same thing.
Yeah, you could just have a column, right? Like I lived in a city, I was born in a city, I worked in a city, right? So that there would be 3 different columns in a relational database. But how do you answer the question if I want, like in Facebook, the standard query would be like, is this person anywhere related to this person? Right. I could write my immediate friends list in my relational database, but how do I answer if this particular person is in the friend circle of any of my friends, right? Then it becomes a recursive call, not it becomes a not a very efficient it's almost a recursive SQL query. So I think with the graph database, the traverse, the way, because we now traverse the nodes, it's not a recursive call. It's not so expensive.
Yeah.
In graph, we'll use some BFS or something like that and to reach the answer more quickly.
Yeah.
But I really want to take some example where we can try to model it in both and then try to see why this is better than the other one. I mean, theoretically, yes, I can understand, but somehow given a problem, will I be able to say concretely, okay, the graph is the one which is the best suited one?
Yeah, so I'm So I'm just doing like a simple Google search, honestly, because I feel like this is probably what would happen at the very beginning. If you were to take some kind of test, right? Probably somebody would just ask you like, oh, one of these questions. So maybe start thinking about it right now, right? Like, so how would you design Facebook, right? Let's pretend that's the question, or the messenger, right? What would you need to start doing?
Design Facebook Messenger. I mean, Facebook and Messenger are different things, but so if they mean Facebook,
Yeah, Facebook or Facebook Messenger. I mean, like so I'm just openly saying it, right? Like these are kind of questions you'd get. So maybe this is relevant too, because we did talk about HTTP and RPC, and so I think this one's kind of like the simplest one that they throw out. I've seen this one before too, like, oh, design a URL shortening service. So like, what would you do, right? Like, what kind of things would you need to put in place? So that could be homework. How would you design YouTube? How would you design the messenger? And think about like those actor model and the messaging priority queue and all that, messaging queue.
Yeah.
This.
Let's I mean, because we are on this graph question, let's answer it. So I think would you want to, yeah, should we next class, should we go over the design question? How would you design social networking site?
Yeah, but I want to give enough time too. So, like maybe, do you feel like next time is enough time for everybody here to prepare? Or do you want to try for like next week?
I think there will be more questions that come out of the initial discussion, and we can I mean, so I think we should also keep it sustainable. Like if you have to do intense reading before every session, I don't find it available. So it should be we should be open to come to this meeting without preparation and still take away something from it, right? Like we should be open to discuss and then go back, and small points also, if you don't understand, go back and then come back next session and understand, answer those.
Sure.
Or we can read together, like if we come up with an article, read at it, read in the, like we do in Amazon, right? We spend like 10 minutes to go over the document and then discuss about it.
I see.
So that way this pressure of preparing before the meeting goes off.
Okay, yeah, I'm not opposed to that, right? Like I'm not trying to put pressure on anybody. I just thought like like a lot of people have said so far that they need more time to kind of be educated to give an answer. So I'm just trying to be fair, right?
Yeah. Like if you come prepared, obviously you will be the most you will be most comfortable talking. But even if you don't, there should be something we still do in this meeting, right? So so I think like to answer Sadhana's question, let's go back and kind of think. You don't not necessarily answer, but like think how would you implement a social networking site. DB, we can start with the DB question, choice of database, and then put some thought into it, and then we can just discuss next time. So does that sound right, Sadhana? Do you want to add something to it?
Yes. I mean, at least we should be able to convince ourselves, okay, this is the best model, or at least to an extent, if not totally. At least we should see something very evident disadvantage in using some other model. If we can come to that point, right, I think we have done good.
Yeah.
Can we focus on a use case then? Maybe a friend recommendation or...
yeah, maybe we'll take that up. Some social network or friend recommendation or whatever. We'll try to do it, brute force into some other model and see why it really doesn't fit in, or something like that.
Yeah, sure. So I think that would be our homework, right? Like
Because until we get that understanding, right? Because these, whenever they say social network or whenever they say a friend recommendation system, we probably know it is a graph data model that we'll need to use. But given a new problem, will we be able to choose a graph? So that's where that's the understanding we'll need to get at, right?
Okay, I think that's a good question that Subha got. So yeah, if your final answer, your final goal is to come up with a, I think this designing even, you design a social networking site where you would be recommending friends. I think that's the recommending friends is like the final goal. But keep that goal in mind while designing your database schema, right? So on the friend, so basically there are, how do you recommend friends? What are the dimensions, like the places, this college, this maybe they went to the same school or same lived in the same city, all those parameters, right? So you need to kind of capture that in a way that your final system can take advantage of, the final design algorithm can take advantage of. Yeah, I think we can just ponder over it. Then so and then we can discuss.
By the way, sorry, not to cut you off or anything, but I think I've seen this guy a couple times in LinkedIn, but I was going to just say it might make sense to also just watch a video, like as part of the homework, and just kind of get a sense of how others solve these questions. And then we can also just kind of,
I would say, because we read some stuff, right? Like we have, before you watch, if you watch something, then, you will be biased toward that solution. It doesn't feel your own. Right? I think you should first think, then discuss, and then, we can go to the final answer. When we are like, have some answer, then we can go and look at the correct answer or the ideal answer.
Sure. I was just saying, like, more sense, like, and I could pick a different question. I was mainly saying it because I was thinking that, if we know, like, how there's like a framework or like some structure to the way they solve it, like, what are they doing? Like each, like let's say the length of it is 15 minutes or 20 minutes. What are they doing in those 15 to 20 minutes? Like, what points do they want to, like, capture? But I'm fine. Like, I can bring that up next time. I think actually, you know what? Let's just free flow for now. Like, I think that's probably a better idea. I think we can do this as a free flow question Friday.
Yeah.
And then see like how others are doing it too.
Yeah. I can, any volunteers for that, or I can also come up and start the discussion on that on Friday.
I think we all volunteer.
Yeah, sure. Okay, yeah.
If you're in this group, you're a volunteer.
Yeah, sounds good. Another. So, so in an interview, right, like when you are asked a design question, we should have a template to approach the design question. So what would, like, when a design question is asked, first we come up with what are the requirements, right? So yeah,
that's what I was trying to come up with, like, by saying the video, but I suppose we can just use like a doc or something. Let's see, what is the template that people use for system design?
The thing in system design is not just implementing just a simple thing, right? It's about scale. Most of the time it's about scale, it's about storage, everything comes into play. Real interview system design, right? It's just not like functional thing. Oh, we want to build a recommendation system. Tell me how would you go about it? But the question is, build a recommendation system for maybe 1 million users, right? Like at a concurrency of 100,000. That's the actual, because there's a lot to it, right? You think about the whole network, the whole architecture, complete architecture, and you got to do the back of envelope calculation, how much storage you need to have,
or even Twitter or something like that, right? We can do this, but still you might have to do that again after this complete the book is done, in my opinion.
Agree.
Yeah, I think that definitely the scale is a design tenet that we should keep in mind. But like when you are thrown a design question, the first thing we would ask is what is the motivation? Like who are the customers? Yeah, we want to ask like what is the scale they want to scale out the solution to. And what are the like what he says, the use cases, the main business use cases, right? So like if you want to make it more advertising friendly, then you want to expose people's interests, stuff like that. So yeah, in a social networking site, right? I think if I am aware of people's interests, then I could kind of publish certain ads. So that could be one use case. Friend recommendation is another use case. So yeah. So how's the other thing? Maybe we are out of time, but like how's the lead code thing going? Is it still on?
So I decided with the team, right, like to just kind of like reduce a little bit of the noise, because I think DSA requires so much focus. So honestly, like we're just kind of at this point, we're not meeting up every day. I think it's more just meet as needed, ad hoc, right? And at that point, like we explain any questions, but there's a GitHub that we're kind of working on and just building, like the solutions there. And then personally, I can tell you that like I've just been really focused on it. Like I've been kind of watching a course and then, going through as many of those questions as I can and then just trying them out locally. And then I know Karthik is pretty far ahead too. And so I don't know, we'll get there. I think I can solve maybe like 20% of blind 75.
To be honest, this is the first time ever I've gone this far. Every time I would start, I would get like, oh, this is like too hard, and like I'll just stop. Now, this is the first time I've come this far. So it's not too far away. Maybe just scratching the surface, but still I'm keeping the momentum. I'm trying to be consistent. And after a while, like it feels like it's so easy. It just it's so daunting initially. I was like, oh, you just got to jog your brain to get to that mode. Once you see that, oh, then it looks relatively easy after a while. Yeah.
I honestly am still struggling to get to, even log in every day.
Interestingly, what I did, right? It'll even be funny if I tell this. I'm sure, Vijay, you're cutting it out. So my big motivation is to move into service engineering teams. I'm more customer facing now, right? So my manager said, don't become a SD. You should go as a SDM. I said, like, no, I don't want to manage people now and stuff. So he's like, okay, what do you want to go? So my career goal, I put that, and he said, okay, then block every day 1 hour and try to work on that. My manager said, right? He's like, oh, it's a two-way door decision. As long as you are within Amazon, I'm more than happy. So just go, block 1 hour every day in the afternoon. If that's exactly what you want to do, go for it, man. Because my utilization is generally only 70% of the customers. I'm not supposed to be 100%. So it works out in grand scheme of things. As long as I get the interviews done, whatever 100 per year that I'm supposed to be doing, whatnot, and so it's okay. So that way I'm consistent because my manager is helping me in some ways.
Nice, yeah.
Nice.
Yeah, I mean, if you want to be part of the group or whatever, just there really isn't a group at this point, just because like we're kind of like still just focused on doing the questions. But you can do the questions and then just ask myself or Karthik if you get stuck. Like how do I attempt this problem? And we'll help you as much as we can, because I think like we got through array, and then I know some of linked list, can probably do tree and recursion. But like, again, there are places where I get stuck too. So, you know, I'm not the best at this yet or anything like
Got
that.
2 flavors going. I'm doing Java for now, and Vijay is doing Python. So
Yeah.
once I'm done with Java, I'll come back to Golang or whatever, like Scala or whatever.
Well, you're doing it in multiple languages. Is there any value to that? Do you think?
I mean, for interview purpose, no value. The reason I do that is I think this is all muscle memory, if you will, right? Not how exactly you solve it, but the patterns of the memory, right? Okay, you see a problem. Oh, this is the data structure you need to apply. This is more efficient. Why? So for that to happen, right? Like I think you need to go to do a second pass or third pass always, right? Practice is the key.
Right.
So instead of just doing in the same old Java language, which has all the data structures already available, right? If you go back to Golang or they just have bare minimum data structure. So you think about it and you build it. So I'm just like, I'll just force myself to actually solve the problem the right way, right? So that's my motivation, doing different language. Ideally shouldn't, but yeah, I always like to adapt different things.
Right. Okay.
Yeah, I recommend. So like for me, I'm doing in Python, and then I can read Java obviously, and I can do it in Java if I want. But like I was thinking of transitioning over to C++ just because like I feel like it's a lot closer to like what exactly is happening. So there was that, and then I guess like not to throw so many people off, right? Like you can still pick whatever language you feel most comfortable with. I was just going to say, like, if you start writing, I would pick Java or Python because like those are the ones that you see everywhere in the world, or JavaScript, right? Like there's a ton of code written in those 3 languages. So if you start working somewhere,
you write
you would
these
need that.
algorithms in JavaScript. Like, does that happen in like real life? Like people write algorithms in JavaScript.
So I personally don't think it's good to write it in JavaScript because like you kind of don't really know what's happening under the hood. You're just hoping that it's, like you're hoping that your compiler is going to do the work for you, right? But it can be done, right? Like at the very abstracted level, right? Like if you still think about like the basic things, like don't use, multiple for loops inside for loops. Like, why would you not want to do that? Or like, if you're going to make a recursive function in you're writing in JavaScript, like what are like if you make 2 different recursive calls, on the same line, right? Like what is the implication of that? Or, if you do a recursive call before you write the return something, or if you return something after you made or if you make some bit of code and then you return a recursive call, what are those key differences? Those are things that, like I think even if you code in JavaScript, you would still need to be able to explain that, So those are areas I think it would be important to know.
But the answer should be, Amulya, you should be saying, do you guys write algorithms? The question is with the amount of memory, CPU, everything available, right? Time, space, and everything. Maybe we won't, they just are testing for the fundamentals. By this exercise is like the fundamentals and the choice of data structures is what I'm thinking. I could be wrong completely. And the system design part comes into heavily play. But I don't know if every engineer is writing algorithm. Maybe not. I don't know. I could be wrong. You might know it better.
If you're using Java, I don't see much reason why.
Exactly. Everything is available, right? All data structures. I'll be even honest, and it's kind of shameless to even say that, right? Over 18 years that I worked with enterprise customers, I never had a need to use stack, queue, and stuff like that. Really not, because most of the times you're just getting done with hash map or array list. That's good enough. You get the job done most of the times. Sometimes, you might use priority queues and stuff.
I mean, I've seen users where basically you want to retrieve something in the order it was inserted in. So those things happen, but not like tree traversal and all. I don't know. But yeah, I think
unless you're writing, let's say, unless you're writing or contributing to open source like like our open search, Lucene, you're contributing something. Yeah, I understand. You'll probably want to write algorithms in the code to be efficient and stuff. I don't know. That's exactly why I am curious to go and see in the SD side of the world, why so much noise? Why is the tech bar so high in the interview? So I want to know. That's where I'm going to go.
To add to that, Karthik, so I have seen this and always have had this question. Why is the interview bar so high where everyday work is bare minimum, feels like anybody can do? That I'm not sure. But I would add to it that yes, HD interviews, like even I was hired as like entry level at Amazon, new grad. And yeah, it was all graph, tree, try. So I don't know. So yeah, for interview,
again goes back, right? I think that they want to test your fundamental knowledge, right? Like, are you making the right decisions?
You to solve the problem, not just get to the algorithm. Basically,
yeah, exactly. Fundamentals and how you're approaching a problem, right? Kind of. That's why in our Amazon interview, you don't have to write a compilable code, right? Even if your algorithm, if you explain the pseudo is good enough, you don't have to actually write it, right?
You do. No, you do.
I mean, you write, but even if you don't end up finishing it, pseudo is good enough. That's what I'm saying, right?
No, not pseudo. Like you have to write minor like if the code does not compile, like minor syntax mistakes here and there is fine. But they still expect you to actually write the code and like in the language with the right usage of everything.
Okay. Yeah, at least the entries that I do, I'm not too stringent on people. Sometimes I feel bad. Initially, I used to feel bad rejecting people. I know I need to find reason why I should not reject them. But sometimes the gap is so big, like you don't have a choice, right? That's why my manager said, over time, you'll get over this. Like some interviews scar you.
I have gone through that, Karthik. I can attest. I had hard time rejecting somebody. I was inclined. Now I've been working, and I can see the regret. The mistake I did.
So basically,
I can attest to this carrying thing.
Going back to that question, where do we need to practice in multiple languages, right? Could you? Is it? That's a good point that you brought up, Karthik. That, but like if your goal, I mean, the reason for why you are doing this data structures and all is for interview purpose. There's no other reason, right? And for interview, you don't need multiple language proficiency. So.
Absolutely not. Yeah, absolutely not. So my motivation is to go only one place, right? I know where I want to go, even in Amazon, right? I know Kubernetes well enough that I lived in Kubernetes for almost 5 years. So if I will go, I'll only go to EKS team. I'm not going anywhere, right? When I'm going there, most of the Kubernetes is written in Golang. So our whole AWS will use Java as well, right? So Java is easy. Golang I've been using, dabbling, but not as good as Java probably. So that's why I just want to.
Yeah.
So just to add there, actually, like different companies look for different things. A friend of mine recently got hired in Meta. And what he said is the problems were not difficult. Like some companies will ask you all these hard problems, right? And they expect how you approach. So apparently, I mean, I don't know, I just know his experience with Meta. But what he said is the problems were not difficult, but they were looking for efficiency, like compilable code in 15 minutes and like 3 problems in an hour.
Oh, so speed.
Yes.
Yeah, that makes sense for Facebook, for sure.
Yeah.
For sure.
So in that case, if Facebook is your goal, then you basically should not bother doing multiple languages. Be familiar with all the syntax and, you know, the things available on a particular like string. What does string have? All those things. So just be familiar with that interface. I think then you will write code fast. Okay.
I mean, it depends how much time you want to. Yeah. So if for my perspective, if one language is getting me a job, I would just focus on that.
Yeah. So I don't recommend my strategy
exactly.
at all.
That's what I was going to say.
Yeah.
Irrespective, just one language is always better for all the companies, in my opinion, for DSA. There's no reason to have multiple languages because end of the day, right? Like think about it, right? Everything is for while there are some syntactic changes here and there. C++ has pointers where you can like, memory management. Java doesn't have it. Like, as software engineers, we will catch up to it. So they're not like, hell bent on like, oh, this language, Rust and stuff like that, right?
Yeah.
So I think one language is always good. And interestingly, everybody has said, choose Python. Okay, there is a reason why they say choose Python, because Python also doesn't have all the data structures Java has. Because if you choose, let's say, a linked list versus array DQ, now you open up the possibilities for the interviewer to ask why this versus that. So you need to have deep knowledge how it's working each. But in Python, you're like, narrowing the scope. If clearing the interview is the goal, Python always tops this thing language. Then because our familiarity is more in Java, yeah, sure. But Java opens up a lot of questions.
Yeah, again, like the reason I picked like these different languages to go through is just because like it's not just enough for me to ace like the DSA and all that. Like, so maybe I should rephrase what I'm saying here. I really wanted to start learning all these other languages because a lot of the older code is written that way. And I wanted to be able to kind of read it if I wanted to someday, right? Like if I wanted to go and look at a C++ example, I wouldn't feel blocked like, oh, I don't know what this is, right? Or if I read something in Java and it's using a whole bunch of like interfaces and abstract classes and stuff like that, I didn't want to feel blocked, right? Like if I pick up, something one day, like Spring example, right? I'm just reading like, oh, how do I create a SOAP web service? And if it's written, in a language that I don't use, I don't want to feel blocked there. So I picked, okay, like for me, what are like the 3 most popular? And so like these have been the most popular since like the beginning of like programming, right? Unless you say, well, no, like before that there was assembly and, like people coded, with assemblers, so I'm not going back that far, right? I'm just like I only care about right now, like getting through like a basic language. So, but for all of you, right, if your goal is like more, you want to just do blind 75, I would pick the language you like. That's it. Yeah. All right. Well, it is 8:46, so I guess we can stop here because I know a lot of you have to drop. But for now, I think like basically let's use this system design template, and then let's start thinking about like one of these questions, and feel free to revise your thoughts like in the chat, and then we can talk about it on Friday.
Yeah. Basically, everyone can, we will all go through turns, and then we'll all have this chance to present what they thought. Don't go through any videos yet. Just from what you think, basically the crude answer, and then let's see different answers, and then we will go through the solution finally. Yeah.
Sure. Okay. Sounds good.
Can you paste the template so I can chat?
Grab it. Okay, of course. Here you go.
Okay.
All right. I'll see you all Friday.
Yeah,
good discussion. Talk to you all. Bye.
Thank you. Bye. Congrats again.
Bye. Congrats.
Of course. Thank you. All right. See you all.